Okay, wishing everyone a happy July the 4th, although it may be after July the 4th before this video actually gets put up. But anyway, what we have here tonight are two Trav-Ler AM radio and phonograph combinations from the late 40s or early 50s. Actually, the one on the left, the dial says Aldens, and the lid has Trav-Ler printed inside the lid. Now, Aldens was a department store brand, and I have been told that Trav-Ler made stuff for them, so who knows. The one on the left is a 78 RPM only unit. The one on the right is a 3-speed unit. I'm not sure if they both share the same model number because the model tag is gone off of the one on the left. The one on the left, the 78 RPM version, was bought by a friend of mine at a local auction, and he said it came out of the local charity hospital that was opened in the 1920s, or let's say the current building was built in the 1920s, and it was in operation until 1989, when our lovely governor of Mississippi chose to shut down all the charity hospitals. And the building has been vacant ever since then. And I think several years ago they had an auction of some of the stuff that was in there, and he said this radio record player on the left came out of there. In recent years, the local community college purchased the property, and at first they were going to tear it down. At first they were going to renovate it. Well, now they've decided they're going to tear it down after they got permission from the Historical Society to do so, claiming they didn't have enough money to fix it. Well, excuse me, it's going to cost millions of dollars to demolish it, plus millions or billions more to build something new in its place, versus millions of dollars to fix the one that's there. So I think that's just more of a case of we want a nice new building. We don't want to fool with a 90-plus-year-old building. Now this unit on the left is in pretty bad shape, actually. The speaker panel is missing. In fact, the whole speaker was gone when I got this unit. And I dug up a speaker out of a junk set. And the chassis is in pretty bad shape, but it's fixable with some patience. However, tonight we're going to focus our attention on the one on the right, the multi-speed player. See if we can get it operational again. So with that said, let's get it in the shop and see what we can come up with. And on the back we have our power cord as well as our antenna wire. Now this is a cheap 4-tube circuit similar to what's used in those little midget Arvin radios. So this is not going to be a station magnet. It's basically going to be good for local reception, but it should do okay for local stations. See, we have this long wire wrapped around here. Okay, let's see what kind of action we get. Our dial light is lighting up. Sounds like our filter capacitor is shot. Okay, let's get started on it. Here's our chassis, and as you can see, this filter capacitor has been replaced before with a Sprague can type electrolytic, and you see how they modified it so they could mount it on the chassis. But it's obviously bad now, so we need to get it out and put something else in its place. And you can see the later plastic insulated wiring running up to the filter capacitor. That's obviously not original to the rest of the chassis. And here's our new filter capacitors soldered in with heat shrink tubing as insulation, so there won't be any shorts. And given how this old capacitor was mounted, I really can't knock them too bad. It looks a lot more professional than some of what I've found and previously worked on radios. In fact, this looks a little sloppy, but, given the small nature of today's parts, it's just easier to install them under the chassis like this and use heat shrink tubing as insulation, since These type of capacitors are either NLA or very expensive in today's world. And two of these newer capacitors are less than $2 for both of them. Okay, I'm running this thing at about 80 volts input because our bulb was getting a little too bright at 120, which usually indicates excessive current in one of these. Oh yeah, we did get rid of the hum, but our audio amp is just barely working. I'm touching the phono input with my finger. So let's make some voltage checks and see what's going on here. And some may ask, why don't you just go ahead and replace all of the capacitors and be done with it? Well, I'll tell you why. Number one, doing that is very boring. Anyone can do that. Well, actually, anyone can troubleshoot a radio if you're willing to learn how to do it. But just changing parts is boring. You know, I would like to actually find out what's wrong with the set, even though I agree they all need to be changed. And number two, as hard as it may be to believe, and if you've watched some of my other videos, you'll know that a lot of the problems I find with these old radios are not entirely linked to bad capacitors. Yes, they cause problems, but there are other things in a radio that can cause trouble too. And I like to show how to diagnose those problems, so when you run into one of those radios that after you magically replace all the capacitors and it doesn't work, then you'll kind of know what to do with it. Okay, I'm now checking the B+ voltage at the plate of the 12SQ7, which is the first audio tube or driver tube. And we're getting about 22 volts, which is way too low. It should be about 40 to 50, maybe up to close to 60. Okay, let's check the voltage on the other side of that 470 k ohm resistor. Okay, I was only measuring about 65 volts on the B+ input to that resistor, so should be more than that. So we'll dig back into the power supply. Okay, so we have a radio chassis where the B+ is not up to par and the tubes check good. And what's likely happening is something shorted is choking the B+ down. It may not be a dead short, but it could be a high resistance leak, if you will. And here's our schematic, as tiny as it is. We'll have to put it under the enlarger. And what we'll want to do is look at every place that B+ voltage is going and see what components are tied to those points, such as capacitors going to ground. Okay, since our audio circuit seems to be the trouble, that's the circuit we're going to concentrate on. And sometimes ohm meter checks can determine when there's a faulty component which is loading the B+ down, and sometimes it can't, because some of these old capacitors won't show shorted when checked with an ohm meter, but when voltage is applied across them, or should I say high voltage, they'll leak like crazy. And the first part on my suspect list is this plate bypass capacitor on the output tube. Its primary function is for tone compensation. So I'm going to remove that capacitor and see what happens. Okay, removing the plate bypass capacitor did nothing. And we have, well, we'll say reasonable voltage on the audio output tube, enough that it should be working if everything else is right. So now we'll move back to our first audio stage. Okay, checking the plate voltage once again of the first audio tube, which I believe we've already done. We're reading about 21 volts. I'd like to see about 30 more volts there, so I think this is our area that we need to concentrate on. Now, what components do we have in the plate circuit here? We have this 470 k ohm resistor that goes from the B+ supply to the plate. We have this 0.005 microfarad postage stamp coupling capacitor that couples the plate of the driver tube to the grid of the output tube. Now that could be leaky, but I'm getting a negative voltage on the grid of the output tube, so I'm really not suspecting this at this time. Then we have this other mica capacitor going from plate to ground, and I know most people think those don't go leaky, but they actually do. or this resistor could be way up in value and keeping our plate voltage down. Okay, I have our 470 k ohm feed resistor taken loose. And it reads 814,000 ohms. So yeah, I would say that one's out of tolerance and could be contributing to our problem. And now that I have the resistor out and it's had a chance to cool down, it's actually reading 1.1 mega ohms. So yeah, it just gets worse, doesn't it? Here's our new resistor, 460K. That's within tolerance. Okay, changing that resistor really didn't help things. And we only have 60 volts coming off of this main resistor in the power supply, which feeds this resistor. It's a 2.2K, so let's pull it loose and check this resistor and see what it measures. Okay, 3.5K, supposed to be 2.2K. I don't think that's up enough to be causing the deficiency that we're having, but since I cut it loose, I suppose I'll go ahead and replace it. Okay, there's our, I think you can see it down in there, our 2.2K ohm resistor replaced, and I went ahead and replaced the plate bypass capacitor. Here's the 2.2K resistor between the two filter capacitors. It's in our filter network. And C8, that's our plate bypass capacitor. And this resistor right here, that's the 470K ohm resistor that feeds B plus up to the plate of the driver tube. It was reading over 1 meg ohm. Now, let's see what happened. Now this plate voltage on the first audio tube is still way low in my opinion. So really the only component that leaves is C7, which is the plate to grid coupling capacitor. And it seems to be okay, but I know these domino caps have a tendency to leak very badly, or I say okay based on voltage measurement. And then on the plate of the driver tube, we have this capacitor that goes from plate to ground, also a domino cap. And on the grid of the driver tube, we have, I believe, a 10 meg ohm resistor to ground. Okay, our 10 meg resistor seems to be okay. So here are the other two capacitors in question. Here's the one that goes from the grid of the plate of the driver tube to ground. And here's our coupling cap here. I believe this domino capacitor is the problem, because with it disconnected, I get, come on, 47 volts on the plate of the driver tube. I can live with that. And when I test on the other side of the capacitor, I get DC voltage. Now, my electronics training taught me that a capacitor is supposed to block DC. So apparently that domino capacitor is the culprit. Okay, this is a Cornell Doublier 0.005 microfarad. Let's analyze this real good. First, let's check it on the ohm meter on the highest 20 meg ohm scale to see if there's any leakage detected on the ohm meter. Okay, on the ohm meter I'm reading 8.9 meg ohms and climbing. And see a new capacitor, I get no reading at all. So now let's move to the old style capacitor tester. Okay, here's the old part tested on a modern digital capacitance meter. It's supposed to be 0.005. Its reading, we'll just go ahead and say 0.02. So that's a tip-off that this capacitor is leaky when one measures higher than it's supposed to on a modern meter. Now let's check it at working voltage and see what happens. Okay, checking for its value. It's not even registering on this old capacitor tester. Now let's check for leakage at 20 volts. Yeah, that's the lowest setting on here. Yeah. Okay, there's our new capacitor. as well as a new 470k ohm grid resistor for the audio output tube, because the old one is reading 800,000 ohms. Now that wouldn't kill the audio stage altogether, but I'm kind of anal about these resistors. They use 10 and 20% resistors for a reason. If it's out of that tolerance, they should be replaced, and 800k ohm is much more than 20% out of tolerance. Okay, let's fire this up, and I have a funny feeling that I'm going to get some audio now. Yeah, we've got some audio. Have a radio station coming in. Well, isn't this nice? The friggin' dial string snapped on us.
Not in the Lord. They're ungodly men that have crept. They have the power to immediately protect you from aggressive collection actions, so the IRS makes an impact.
Okay. That's a lot better. And we still have to deal with that popping that I'm hearing every now and then.
Last night when people started canceling.
Oh, and by the way, here's the plate bypass capacitor of the audio output tube, also leaky as all get out. And what threw me off on this capacitor C7 being bad is the fact that I didn't have a major positive voltage here on the control grid of the output tube. Actually, I had a very slight negative voltage, but I think probably what was happening, this capacitor was so leaky that whatever positive voltage being developed on the grid side of the capacitor was being choked down by either the tube being overdriven or by this resistor, this 470k ohm resistor to ground here. But at any rate, that capacitor was bad. That tone capacitor was bad, or plate bypass capacitor. And you know, within reason, the rest of these boogers are bad too.
For $39.95 or less.
Okay, I replaced the rest of the old paper capacitors, and that eliminated the intermittent, erratic popping sound that we were hearing. Most likely what was happening is one of those old capacitors was probably on the verge of shorting and was arcing internally. And that's what was causing the popping in the speaker. It's just a theory that's by no means should be taken as gospel.
Which indicates
and there we go.
They're claiming that we live on.
I think I've about wasted enough time on this video, so we'll stop here. And on the next installment, we'll do the RF and IF alignment, as well as repair or restring this dial string, whichever is needed. And like I said, this radio is not going to be a station mount because it's only a 4-tube set. It does not have an IF amplifier stage. The mixer stage is coupled to the detector and first audio stage via this IF transformer here. Okay, before we go, let's check the negative grid voltage on the audio output tube. Before, with the old bad cap, it was teetering around like negative 0.5 volts or something. So let's see what we have now. Now my meter is wanting to act stupid for some reason. Okay, now let's see if we can get some action here. Negative 8.5 volts. Yeah, that's a lot better, isn't it? Okay, there you go. We're done for part 1. In part 2, we will do the alignment and restring the dial, and we might even start on the phonograph portion.